Okay, are we here? I think we have a. Hang on. Uh, Not without equipment problems. I got to reset the microphone levels. Sometimes Microsoft decides that it just needs to reset all of the levels. So I'm going in here. Okay, let me know if you guys can't hear me okay. I'm showing my levels look a little bit weak here on this microphone input. All right. I think I'll just bring it up all the way up to the red. Let's see here. All right, guys, let's try that. Sorry about that. I took a little bit of a break here over the past day, and I was out traveling to Dallas, and I ended up rolling in here about 7:55 right before the webcast, and I was pretty wiped out, so really had to take yesterday off. But that gives us a chance to catch up, and we can see the low temperatures for this morning. Lots of 50s across Texas, and it feels like April. In fact, we got 70 right there at Houston and 70 at Corpus Christi. Ridiculously warm weather. But a little bit more seasonal up in the north. Got a lot up there in Montana and South Dakota. And out on the East Coast, looks pretty typical, maybe a little bit on the warm side, but got 40 there at New York City, 7 to 40 all the way down to the Charlotte area. Kind of sets the stage for what's happening. It's kind of a mild pattern, and let's go over the frontal analysis. This is looking at the thickness and isobars. See the strongest banding of the thickness lines located front, make southward. The edge right there from Las Vegas to Red Bluff through Midland and south of Dallas, and then the western edge. That's probably going to be a warm front. Exactly, could be from the Carolinas, across Virginia. Probably looking more at this area right here, maybe anywhere from South Carolina to Virginia. The reason we have to look at the surface analysis and get the actual story on what's happening. See, we got 66, 64 here in southern Georgia. Falls off to 50s and 40s there in the Carolinas. So actually we have a little bit of cold air damming going on. See the front looking kind of like that. Warm front, cold front portion, that's going to be extending rock, and then there it is south of Dallas. Temperatures behind that pretty mild, and then north of that into Illinois and Indiana, that's probably going to be more of an occluded front. It's the picture, what's happening right now. And I figure we can take this opportunity to look at some of the experimental SPC products. Search engine, put an SPC experimental. Mesoanalysis graphics, and is there weather happening? Let's try the eastern U.S. We haven't looked at them in a while. See some showers moving through around Nashville, north of Huntsville, Mississippi area. So that we know already from looking at that basic analysis that's going to be ahead of that cold front. In fact, fine line edge right there. Looks like the rest of what's happening is probably just kind of a weakly capped air mass. This is probably ahead of the surface boundaries. It's going to be probably ahead of that occluded front. So they give us a couple of options here. Panel, there's 5 products there, and the surface, upper air, there's a ton of them. Now, it's important to keep in mind that these, for the most part, are not observed values. These are computed from the rapid refresh models, so you have to kind of keep that. There's going to be a little bit of smoothing. Might get better detail using RAYOB or that actually analyzes the soundings instead of using. You'll get a slightly different picture between using model diagnostics and observed data. Surface observations, those are going to give us the actual observed data. Those are our observations. Visible satellite, of course, that's going to be dark since the sun is side of the globe. Base data, that's already printed. Add profiler data. Never actually used that, and it doesn't seem to expect that would give us winds aloft or something like that, but look at a couple more of these. Surface MSL pressure and wind. Now we know that could be either sea level pressure, altimeter setting. We don't know which one. However, we can see the values are calibrated. These are millibar values, not inches. So this is going to be sea level pressure. Temperature, wind, dew point. Of course, that's going to give you your standard chart that you're going to see on a chase day. The brown lines are going to be your temperature, and the blue lines, those are going to be your moisture values. And you can see that there's a correlation with this area of showers here and the higher dew point values. See how they're kind of clustered here, the blue dew point values? Because the higher dew point values are kind of extending north like that, and they're kind of showers. And then up here, this is probably going to be elevated moisture. So some of this moisture that you see down here, that's probably elevated over that frontal boundary. What else do we have? Moisture convergence. That's where wind flow is bringing the higher values of moisture together. It's kind of a combination of dew point and convergence. Looks like the best moisture convergence is way down to the south. For a while, moisture convergence was used, and I'm talking back in the 60s and the 70s, for looking for initiation. I know there's been a couple of researchers like Chuck Doswell and others. They've advised using strictly, because when you mix in two diagnostic values, you're kind of hinging on both of those to accurately represent what's going on. If you start adding more and more values in, that's something that a lot of stability indices do, especially the older ones. And that's one reason I don't use a whole lot of those too much. See that on the thermodynamics manual, they kind of panel, they forecast, slow down. They're including mostly just CAPE here, LCL, and LFC. That's pretty good. But on some upper air panels, you'll have a lot of other indices like index, Walter index, K index, total totals. These get a little bit more risky to use because they're mixing up a whole bunch of different. One of them is not representing. Parameter that is, I guess what I'm trying to describe is the pieces that go into each of these parameters. Each one of those has to be accurate, or they can kind of like sabotage the rest of the terms in there, and you end up with a little bit less reliability in those derived indices. So it's best to use like the ones that actually use like single bits of raw data. CAPE would be one of them. It looks strictly at temperature difference from the surface on up to like the tropic. That's a relatively simple X, and that's why I like to use that a lot. Cape and okay, I didn't want to get too long-winded here. Let's see, let's just go ahead and go into the forecast and see what's going to happen. I've got both the GFS and the Canadian GDPS model here all set up. Let me get that centered. Here we can see the front moving southward, and part of it is coming through Arizona and New Mexico, Las Vegas. See that here? See if the data represents that. It should be showing kind of a southward push of go out west, and yeah, you can see there's kind of a weak indication of any frontal activity. We've got north winds there at Salt Lake City and temperatures in the 20s. Price has northeast winds and 22 degrees. Also pretty cool in the Winnemucca and Ely area. Down to the south around Phoenix, we've got a southwest wind right there. Calm through this area, and then we've got an east wind at Las Vegas. This is probably suggesting, yeah, we've probably got the front, very weak front through this area right here. And in Colorado, and then south of that, we pick up that west-southwest flow right there. So let's see, over the next week or so, or over the next, day, webcast tomorrow, it's going to be Thursday. We're going to see that cold front push southward through Texas and clear a lot of the southeast U.S. Development of a closed low in the New York City area. See where that comes together. Get an open trough right there, and then that firms up into a closed low right around Long Island. It's off the edge. Sorry about that. Okay, so there it is. There's that frontal system coming together, and then 12 hours before that, it was kind of just most of the cold air advection is going to be centered on this area here, eastern U.S. High plains right there. So not very good for cold weather on the Great Plains itself. Kind of a weak cool down as some of it filters southward, then the brunt of the coast. Friday, the day before Eve. Air advection pattern spreads across all of the Midwest Great Plains, and there it is right there. We have another front working to the south. Clipper coming southeastward. For New Year's Eve, the Alberta Clipper works southward, kind of divides up into two different pieces. Get a little bit of upslope flow here, a little bit of higher humidity in the Amarillo, Lubbock, and Lamar area. Then on the other side, we've got some pretty strong warm air advection off the Gulf, and like that's favoring some showers around Houston to Beaumont, back to New Orleans, and then through the Mississippi. And for the first day of 2017, there we go. Kind of a very broad warm air advection pattern through part of the country. Then we get southern Alberta Clipper developing. Second, that makes its way southward, and we can see the high pressure area kind of developing, and anticyclogenesis, probably some subsidence back behind there. So this is intensifying a little bit. Moist warm pattern continuing over the southeast U.S. Then things get interesting on the 3rd. System coming southward. See it really builds in on the 4th. So we should see things change quite a bit on Wednesday next week. Strong cold air advection pattern pretty much across the entire country. I'm going to show you something here on the Canadian model. A big difference coming up for the West Coast. So you see here on the 5th, West Coast looks pretty clear. Bulk of the cold air heading southward. Look at that, it got a little bit of snow and freezing rain developing in the San Antonio area. Very strong southward push through here, but it's showing, the GFS here is showing kind of a stagnant pattern across the western U.S. Now here's where the difference is. I'll run up to the 4th. See that there's a stronger push in Nevada right there. See that there's a little bit stronger intensity of that gradient right through here. Flagstaff, Las Vegas, and Reno. Then around the 5th, what happens? System coming on shore here around Southern California. So it actually picks up that boundary. And by the 6th, we've got a big system coming in there into Los Angeles and San Diego. Casting very heavy rain there in the Los Angeles Valley. Heavy snow in the mountains, Los Angeles, San Bernardino. Heavy snow in the deserts there. Desert into the Las Vegas area. Is that going to pan out? I don't know. If we had the ECMWF, the European model, that could help us out a bit, but we don't have the luxury. So that could be quite a potent system there in the Southern Rockies if that comes together, and that would definitely have an impact on Texas and Oklahoma and Kansas as that shifts eastward. Probably, yeah, you see this cold air advection coming in here into the Great Basin area. When we see that, that tends to have a very strong effect on the Great Plains as that comes southward, because if you're going to get that strong of a cold air advection push across these mountain ranges like this, that tells you that that's going to be a very deep and pronounced outbreak of cold air. It'll be interesting to see which way the models go on this. A question coming up for next week. And then we get to the end of the run here. Pacific system becomes kind of active. Looks like the GFS does bring something in on the 9th through California. More fun weather for the central U.S. here. 12th through 13th, developing a winter storm right there in Oklahoma and Kansas. But this is 384 hours out, so that could just be a cold GFS bias. And I think that's probably about all I got here. Take a look at the chat here real quick. Voice a little bit. Audio cutting in and out. Okay, I got you guys. Sorry about that. I'm going to have to run some tests on this and see what's going on. Okay, yeah, sorry guys. I'm going to have to do some... I'm going to have to figure out what's going on with my audio board here, and if I get it worked out, I might try to run a webcast later. I will see what happens with that. Anyway, sorry guys, and we'll give this another shot either later tonight or tomorrow. But I do appreciate you watching, and we will get this thing back on track in the next couple of days. Sorry. Anyway, have a good evening, guys.